Okay, I want to try to clear up any confusion as to the difference between grounding and bonding. In your panel, you have a grounding bus bar, and it has lugs that you can put wires under. And this grounding bus bar is taken to earth. I mean, quite literally, there is a copper ground rod, and this grounding electrode conductor goes to that ground rod, and it takes this grounding bus to earth. That's a ground. So I'm going to get a little bit technical here. At the very first receptacle, this green wire coming back to the panel is known as a ground because it is going to ground. This is the equipment grounding conductor, ING. Subsequently, all other receptacles downstream from that first receptacle, technically speaking, this is no longer a ground. It's a bond. We will refer to it as the ground. When you're on the job site, they'll refer to it as the ground. Get used to the fact that when they say ground, they mean that this green wire is going all the way back to the earth. It's grounded, okay? But the difference between a ground and a bond, if I have a metal cabinet, here's a piece of metal, and here's another piece of metal. Maybe it's a motor out in the middle of the room here, okay? I'm going to take a wire from this metal, and I'm going to run it over to this motor, and I'm going to attach it to this metal. Now they're bonded. They're bonded together. To connect, to make electrically joined, is bonding. So they're bonded together. Technically speaking, like I say, between the first receptacle and all subsequent downstream receptacles, these are technically an equipment bond. Equipment bond. But we're not going to be that exact on the job site. We're just going to call them the equipment ground, the grounding conductor. Okay? So they'll tell you to attach the grounding conductor or to run the grounding conductor. They mean the green wire that goes on the green screw. And it probably also, if you're using metal boxes, you're also going to take a pigtail to the metal box so that the metal boxes are also bonded or grounded, however you want to say it. But a bond is connecting two metal pieces of equipment together to make them electrically at the same potential. And when you take one of those ground wires, one of those either bare or green, when you go back to the earth, now it's grounded. So that's the difference between a ground and a bond, or grounding and bonding. Like I say, it's a little bit more technical than we really need to be at this point. If you're running 3 wires and one of them is green, that's the equipment grounding conductor. Even if it's not going all the way back to earth, eventually it's getting there. It's going to be bonded to another equipment grounding bond that goes, and eventually it will be married with the equipment grounding conductor, and, or I should say the equipment bonding conductor would be married to the equipment grounding conductor, and they will find their way back to earth, back to ground. Okay? So don't let that confuse you too much. Just they were using the term equipment grounding and bonding of metal equipment, and I wanted you to know basically it's the same thing, grounding and bonding. You know what, I don't need to put that away, I can just leave this here. All right, let's go back. There you go. 1.3.0 metal conduit fittings. There are many conduit fittings available to do electrical work. The type of conduit fitting used in a particular application depends on the following: the conduit size and type, the fitting type needed for the application, the fitting's location, and the installation method. When using a combination coupling, be sure the flexible conduit is pushed as far as possible into the coupling. This covers the end and protects the conductors from damage. Requirements and proper application of boxes, conduit bodies, or fittings are found in NEC section 300.15. Some of the more common types of fittings are covered in the following section. 1.3.1 Couplings. Couplings are sleeve-like fittings threaded inside to join two male threaded pieces of rigid metal conduit or intermediate metal conduit. Figure 10 illustrates a variety of metal conduit couplings. So this is a conduit coupling. This is a short piece of pipe. This is a two-piece hinged coupling. Here's a three-piece coupling. When you can't turn the conduit, you can use a three-piece coupling. Here's a concrete tight set screw type of coupling. Here's EMT to rigid. The threaded side is for the rigid. The set screw is for the EMT. Insulating bushing. Here's a highlight. Non-grounding insulating bushings protect the conductors from being damaged by the sharp edges of the threaded conduit end. NEC section 300.15c requires that where a conduit enters a box, fitting, enclosure, or conduit termination, a fitting must be provided to protect the wire from abrasion. Especially if it's 4/0 or larger, you have to have a conduit bushing. Here's a highlight. NEC section 312.6c references section 300.4g, which states that where ungrounded conductors of number 4 gauge or larger enter a raceway in a cabinet or box enclosure, the conductors must be protected by an integral threaded hub or boss or an identified listed metal fitting that provides smooth, rounded, insulating surface unless the conductors are separate from the raceway fitting by a substantial insulating material that's securely fastened in place. So then they give you a couple of sections. You should go look those up in your code book, 312.6c, 300.4g. Here are insulating bushings. They used to be called fiber bushings. Now they're called plastic bushings or insulating bushings. This is what they look like. They screw on the end of the connector that goes in the box, and they protect the wires coming out of the pipe and the connector from sharp edges. Use grounding insulated bushings or grounding bushings to protect conductors. They also have provisions for connection of an equipment grounding conductor. The ground wire, once connected to the grounding bushing, may be connected to the enclosure to which the conduit is connected. So here's a grounding bushing. Put that on the end of the pipe, and it has the fiber or plastic sleeve that protects the wires from abrasion. And then it has a lug that you can put an equipment grounding conductor or a bonding conductor underneath this hub, and it can be taken to the box, and that bonds the conduit to the box in a very substantial way. 1.3.3 threaded weatherproof hubs. We call these Myers hubs. You know what? I'm going to go ahead and highlight that. Known as Myers hubs. So these rigid connectors are known as Myers hubs. They screw onto the end of the rigid conduit, and then threads will go up through the box, and then you'll put this lock nut on. Well, they have a gasket. They're gasketed. So it's a very good way of running the conduit if it's outdoor to make sure that no water gets into the cabinet. 1.3.4 offset nipples. Offset nipples are used to connect two close pieces of electrical equipment where a slight offset is required. So you have two boxes. Well, this actually goes to a conduit. So this goes to EMT. Instead of having to bend an offset on the conduit, you can use this offset nipple. And this one goes between two boxes. So you have two boxes that have factory installed knockouts in the box, and the knockouts are not lined up. You can use this offset nipple to connect those two pieces of equipment together. 1.3.5 conduit bodies. Conduit bodies, also called conduits. That's a highlight. Conduit bodies, also called conduits, are fittings that let you access conduit through a removable cover. Through a conduit body, you can access the system's interior at a junction of two or more sections of the system, a pull point, or at a terminal point of the system. So conduit bodies are usually cast and cost a lot more than the stamped steel boxes permitted with EMT. Unlike stamped steel pull and junction boxes, conduit bodies do not have to be supported. All right, so situations when conduit bodies would be preferred include use in outdoor locations, for appearance's sake, in an exposed location, to change types or sizes of raceways, when elbows or bends would not be appropriate. Maximum number of conductors permitted in a conduit body is found using NEC section 314.16b1. This information is summarized in NEC table 314.16b1. Here's a highlight. Type C conduit bodies are used to provide a pull point in a long conduit run or a conduit run with bends totaling more than 360 degrees. So here's a C conduit. That's a pulling C. Here's another highlight. It says type L conduit bodies are available with a cover on the back, LB, on the sides, LL or LR, or on both sides, LRL. So this is an LL. If you hold the short piece, if you hold it like a gun, the cover's on the left. That's an LL. If you hold this one like a gun, the cover's on the right. That's an LR. This one, the cover's on the back, so it's an LB. There's another one. Here he is holding it. This is an LB. There's one called an LRL. It has an opening on both sides, both the left and the right. Here's a T conduit. You are allowed to make splices in a conduit if it's stamped with its cubic inch area. So if the manufacturer has stamped it with its cubic inch area, you are allowed to make splices inside of it. Type X conduit bodies are used to provide a junction point of 4 intersecting conduits. Here's a type X. Sealing fittings. NEC sections 501.15 and 502.15 require sealing fittings for conduit in hazardous locations where explosions may occur. The NEC also requires them where a conduit passes from a hazardous location of one classification to another or to an unclassified location. Seal-offs are to prevent the exchange of environments. So if you have an environment that has explosive gases, a Class 1 Division 1 location, and there's a conduit running to a non-classified location like an office or an electric room, you need to put a seal-off where the pipe, right before it enters the ground, within 18 inches of the ground, you put one of these seal-offs. And you fill it with something called Chico that is like plaster of Paris, and it keeps the exchange of atmospheres. It prevents any gases or vapors from moving down the pipe into the electric room. So it prevents any explosions. So here's a sealing hub, here's a rotating spout. This one's a drain. The drain will allow the accumulation of moisture in the bottom of this drain, and it uses positive pressure. There's a little bit of water in here, and the water has a surface tension. It won't drain out all of the water. If the water accumulates, it'll allow it to drip out. Drip, 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 drip. But there will always be some moisture in here, keeping this sealed so that the air from the environment does not get in here. So it's like a one-way valve. Making a conduit to box connection, we're going to use a connector. Means must be provided in each metal box for the connection of an equipment grounding conductor. This means must be permitted to be a tapped hole or equivalent based on section 314.100D. Proper conduit-to-box connection is shown in figure 20. So here is an external lock nut and an internal lock nut, and they are grabbing this metal box. If there's any kind of paint or enamel on the inside or outside of this box, you need to scrape it off so that these make good contact. And then you put the fiber bushing or plastic bushing to protect the wires. Bushings protect wires from sharp edges of conduit. As previously discussed, bushings are usually made of plastic or metal. Some metal bushings have a grounding screw to permit a bonding wire to be installed. Lock nuts are used on the inside and outside walls of the conduit to which the conduit is connected. Walls of the box, excuse me. You may need a grounding lock nut if a bonding wire is to be installed. Special sealing lock nuts are also used in wet locations. So if the conduit does not enter straight into the box, it would require a box offset or a kick to be made in the conduit. A kick is anything less than 90 degrees. A bend in a piece of conduit, usually less than 45 degrees, made to change direction of the conduit. I'm not going to go over those directions. 1.5.0 Raceway Supports. Raceway supports come in many types and configurations. This section discusses common supports found in electrical installations. Straps. Straps are used to support conduit to a surface. The spacing of these supports must conform to the minimum support spacing requirements for each type of conduit as indicated below. So a one-hole and two-hole straps are used for EMT, RMC, IMC, PVC, and flexible metal conduit. The straps can be flexible or rigid. Two-part straps are used to secure conduit to electrical framing channels. Parallel and right-angle beam clamps are also used to support conduit from structural members. Here's a highlight. It says, clamp back straps can be used with a back plate to maintain the quarter-inch spacing from the surface required for installations in wet locations. Maybe not even a wet location. Maybe it's in a kitchen where they might hose down the walls regularly for cleaning. The pipe needs to be a quarter of an inch off of the surface in order to allow the water to drain and for the pipe to dry so it doesn't corrode, it doesn't rust. So here's your clamp strap and the rigid back strap that goes with it. Standoff supports. Here's a standoff support. I think we call them Mineralac straps. Standoff supports are used to support conduit away from the structure. The support is often called a Mineralac strap, which is the name of the manufacturer of this type of support. So standoff supports are often called Mineralac supports or Mineralac straps. There you go. In the case of the one-hole and two-hole straps, the conduit must be offset wherever a fitting occurs. If standoff supports are used, the conduit is held away from the supporting surface and no offset is required for the conduit and the fitting. So this looks like 1.125" unistrut, and the conduit is held on with a unistrut strap to whatever size this conduit is. Electrical framing channel. Electrical framing channel or other similar framing materials are used together with unistrut conduit clamps to support conduit. So here's their framing channel. Unistrut, B-line. There are several different manufacturers of this type of holder. Electrical framing channel. Beam clamps. Beam clamps are often used with suspended hangers. The raceway is attached to or laid in the hanger. Hanger is suspended by a threaded rod. One end of the threaded rod is attached to a hanger, and the other is attached to a beam clamp. So here's the beam clamp. It's held on with this set screw on the side of the beam, and it has a 1/4, 20 threaded hole, or a 3/8 threaded hole, whatever size you got for whatever size all thread you're using. And you can make that up to 6 feet in length. If you needed longer, I guess you could use a coupling nut and some check nuts to make sure it doesn't come undone. When conductors are bundled together in a wireway, their magnetic fields tend to cancel, thus minimizing inductive heating in the conductors. Okay. Boy, this just goes on forever. 1.6.0 Installation requirements for various construction methods. Conduit and box installation varies with the type of construction. Following sections discuss special requirements for masonry and concrete, metal framing, wood, and structural steel conduit construction. So working in masonry and concrete flush-mounted construction, here's a highlight. It says, ordinary boxes may be used, but special concrete boxes are preferred and are available in depths up to 6 inches. These boxes have special breakaway ears by which they're nailed to the wooden forms of the concrete. When installing them, stuff the boxes tightly with paper to prevent concrete from seeping in. Figure 25 shows an installed concrete box. So here's the form, and then you nail it to the side of the form. When after the concrete hardens, they're going to take this form off, and those little ears will just break off, they'll snap off. And then you stuff it full of paper, or sometimes you'll wrap it in duct tape, and it just keeps any concrete from getting inside. Flush construction can also be done on existing concrete walls, but this requires chiseling a channel and box opening, anchoring the box and conduit, and then resealing the wall. To achieve flush construction with masonry walls, the most acceptable method is for the electrician to work closely with the mason laying the block. Together they can ensure the box is properly grouted and sealed. When the construction blocks reach the convenience outlet elevation, boxes are made up as shown in figure 26. Sections of the conduit are then coupled in short lengths, approximately 3 to 5 feet. This is done because it is impractical for the mason to maneuver blocks over 10-foot sections of conduit. So here's the box. It has a large plaster ring on it that the concrete block wall, they'll chip out this shape, and then you can put your box in so that it's flush with the front of the block. And then, like they said, we're going to cut these to 2 or 3 foot pieces. They said 3 to 5. Even 5 is a little bit long for them to have to. The next block they put on, they have to lift up over the top of that conduit and then bring it down, and then put it in place with the grout border. Figure 27 shows masonry box that needs no extension or deep plastering to bring it to the surface. There you go. So this one is just going to be flush. It has the screw holes for devices, and you tape it up with duct tape to make sure that no concrete gets inside of it, and your conduit is coming out of the top. Working in a metal stud environment. Metal stud walls are a popular method of construction for the interior walls of commercial buildings. Metal stud framing uses relatively thin metal channel studs. The studs are usually constructed of galvanized steel and have an overall dimension the same as standard wooden studs. Wiring in this type of construction is easy when compared to masonry, and they don't get termites, they don't rot. There are a lot of good benefits from using metal studs. EMT conduit and metal-clad cable are the most common types of wiring method for metal stud environments. Metal studs usually have some number of pre-punched holes that can be used to route the conduit. If a pre-punched hole is not located where it needs to be, holes can be easily punched in the metal stud with a hole cutter or knockout punch. Some of them we call them can openers, but these are the pre-cut holes already in the metal studs. So if the framer mounted these correctly, you can run your conduit right down the middle here. Sometimes they get mistaken if one of these gets turned over so that the holes are off center. Well, you can just use a can opener stud punch and just punch a hole in it and you're ready to go. Here's a highlight. It says it's important to know what the finished wall thickness is going to be to properly secure the box to the metal studs. For example, if the finished wall will be 5/8 of an inch drywall, then the box must be fastened so that it protrudes 5/8 of an inch from the metal stud. Warning, when using a screw gun or cordless drill to mount boxes to studs, keep the hand holding the box away from the gun or drill to avoid injury. According to NEC Section 300.4B1, non-metallic sheath cable run through metal studs must be protected by listed bushings or listed grommets. There you go. You don't want these to get cut on the sharp metal studs. You have to put these grommets in place and then run the wire through them. Let's see here. 1.6.3, working in a wood frame environment. At one time, the use of rigid conduit and partition and ceilings was a time-consuming operation. Now, thin wall conduit makes it an easier and quicker job, largely because of the types of fittings that are especially adapted to it. Figure 30 shows two methods of running thin wall conduit in these locations. Let's take a look. So they're running it through holes in the studs. Sometimes you like to just bring it up into the attic and run along the header and then bring it down into the air chase between the studs wherever you need it. It's sometimes easier to do it that way than to run it horizontally through all of the studs. When boring holes, holes must be drilled large enough for the tubing to be inserted between the studs. The tubing is cut rather short, calling for multiple couplings. EMT can be bowed quite a bit while threading through holes in studs. Always wear safety goggles when boring wood. NEC Section 300.4 addresses the requirements to prevent physical damage to conductors and cabling in wood members. By keeping the edge of the drilled hole 1.25 inches from the closest edge of the stud, nails are not likely to penetrate the stud far enough to damage the cables. The building codes provide maximum requirements for bored or notched holes in the studs. If you can't maintain that, you have to put a nail plate. Here's a highlight. Nail plates are also required to protect the conductors in all notched wooden members per NEC Section 300.4A2. And it says 300.4A1 requires the use of steel plates or bushings at least 1/16 of an inch thick, or a listed steel nail plate where wiring is installed through bored wooden members less than 1.25 inches from the nearest edge. And that keeps the drywallers from putting screws through our wires. Working in metal buildings, many commercial and industrial buildings are prefabricated structures with steel structure supports and roofing and siding made of light gauge metal sheets. Conduit can be routed across the structural members that support the roof. So they're saying that you can actually put your conduit through these purlings here. You can just run it along and secure it. Avoid drilling through beams and purlings. Instead, conduit should be supported from the metal beams by anchoring devices designed specifically for that purpose. The supports attach to the beams or support and have clamps to secure the conduit to the structure. All conduit runs should be plumb since they are exposed. Bends should be correct and have a neat and orderly appearance. Remember, plumb is when it's level in a vertical orientation. It's plumb. Rigid metal conduits often required in metal buildings. If a large number of conduits are run along the same path, strut type systems are typically used. You make what's called a trapeze. This is a trapeze. Use a unistrut and use the all thread with beam clamps holding this all thread, and then all of your pipes can go on the trapeze. You make it as long as you need it for however many pipes you have coming in the area. Strut type systems are sometimes referred to as unistrut systems. Unistrut is a manufacturer of these systems. Another manufacturer of strut systems is B-line systems. Both are similar. Okay. 1.0.0 section review. So go over these turn them into your instructor. I'll meet you on the next section. All right. Section 2.0.0, Fasteners and Anchors and Raceway Systems. Explain how to select fasteners and anchors for the installation of raceway systems. So describe how to select and install zip ties, screws, hammer-driven pins and studs, stud-type guns, masonry anchors, hollow wall anchors, and epoxy anchoring systems. And then there will be a performance task. Your instructor is going to want you to identify and select various types of and sizes of raceways, fittings, and fasteners for a given application. Demonstrate how to install the raceway systems and terminate a selected raceway system. Conduit and other types of raceways that carry wiring and cabling must be properly supported. You may have to attach raceways to wood, concrete, or metal. You must use fasteners designed for the use with the specific type of material. Using the wrong fastener or installing the right fastener incorrectly can lead to failure of the raceway support. Project specifications and manufacturer's installation instructions may list types, the type and size of fasteners to use and how to install them. If not, the electrician must select the right type of fastener. In this section, you'll learn about different types of fasteners, their uses, and their limitations. Uh, 2.1.0, using zip ties. A zip tie is a one-piece self-locking cable tie used to fasten a bundle of wires and cables together. They're typically made of nylon, may be called cable ties or tie wraps. Zip ties are made in a standard cable strap and clamp and identification configuration. Zip ties can be quickly installed either manually or using a special installation tool. Zip ties that resist ultraviolet light are recommended for outdoor use. Special rated zip ties may also be required for use in return air sealings. That's a plenum, return air. For these instances, consult local requirements. So here's your standard zip tie. Here's your releasable. You can actually push this tab down and you can release it, reuse it. This is a zip tie with an eyelet so that it can be screwed and secured. Then you can still use the zip tie. And here's one with an identification tag. You can print the tag or write it by hand and put it on there. It says, caution, do not over tighten any wrap or cable tie as it may result in electrical interference between the conductor and or damage the cable. Releasable tie wrap version is also available. It's a non-permanent tie used for bundling wires and cables that may require frequent additions or deletions. Cable ties are made in various lengths and colors. Tie wraps can also be attached to a variety of adhesive mounting bases made for that purpose. Always check the job specifications to ensure that you're using the correct cable wrap or tie. 2.2.0, using bolts and screws. Bolts and screws are made in a variety of shapes and sizes for different fastening jobs. The finish or coating used on a bolt or screw determines whether it's for interior or exterior use, corrosion resistant, etc. Bolts and screws of all types have heads with different shapes and slots. Some have machine threads and are self-drilling. Refer to Table 4 for metric and SAE, or Society of Automotive Engineering sizes of screws and bolts. So here are some standard ones we use. We use 1/4-20. It's a 1/4 inch diameter stud with 20 threads per inch. This is fine. This is coarse and fine. Fine is 28 threads per inch. 5/16 with 18 threads per inch, and if it's a fine thread, it's 24 threads per inch. we're more and more running into metric sizes of screws and bolts. But this whole chart goes over them all. I'm not going to cover them all. Just know that fine means there are more threads per inch than coarse. Size or diameter of the body of the shank is given in gauge numbers ranging from 0 to 24 and in fractions of an inch for screws with diameters larger than a quarter inch. The higher the gauge number, the larger the diameter of the shank. Lengths are measured from the tip of the part of the head flush with the surface when driven. Let's see if they gave us any drawings on that. All right. We'll try to find it later. This is when choosing a fastener for application, you must consider the type and thickness of the materials to be fastened, the size of the fastener, the material it's made of, the shape of its head, and the type of driver. Here we go. Here's good. So they were saying that the length of the screw is measured from the part of the screw that's going to be flush with the surface and the tip of the screw or the bolt. So this type with an protruding head would be measured from the bottom side of the head to the flat of the bolt. And if it was countersunk, let's see, they don't have, okay, these are countersunk. They're meant to actually be depressed, be countersunk into the wood or the surface so that the top of the head is flush with the building material. So you'd measure from the top of the screw to the point, and that would be the length of the screw. Okay. If the bottom of the head is flush with the material, you measure from the bottom of the head to the tip of the screw or bolt, and that's what your measurement is. If they're countersunk, you measure from the top of it, where it's going to be flush with the surface, to the tip. Now, I call these screws because they have a point and they're meant to make their own hole as you push them in. As you screw them in, they'll define a hole. I call this a bolt because it has a flat point to it, a flat tip, and it will not self-thread. It will not make its own hole. You have to thread it with a tap. Use a tap set and tap a hole, and then this bolt will go right in. Or you slip it through something with no threads at all, and you put a 1/4-20, or you put a nut, a hex nut on the back end of it, maybe with washers. Let's see, using lag screws and shields. So these coarse threaded screws are called lag screws. They're really good for holding because they have a shield, a sleeve. You drill a hole just big enough for this sleeve to go in, and then as you screw the lag screw in, it spreads these two sleeves out and they push on the outside of the hole. It says lag screws or lag bolts are heavy-duty wood screws with square or hexagonal shaped heads that provide greater holding power. Lag screws come in a wide variety of sizes and diameters. They're typically used to fasten heavy equipment to wood, can also be used to fasten equipment to concrete when a lag shield is used. And here's that lag shield. Lag shield's a tube split lengthwise but remains joined at one end. It's placed in a pre-drilled hole in the concrete. When the lag screw is screwed into the lag shield, the shield expands into the hole, firmly securing the lag screw. In hard masonry, short lag shields may be used to minimize drilling time. In soft or weak masonry, longer lag shields should be used to achieve maximum holding strength. Make sure to use the proper length lag screw to achieve the proper expansion. The length of the lag screw should be equal to the thickness of the component you're fastening plus the length of the lag shield. Drill the hole in the masonry to a depth slightly longer than the shield you're using according to the manufacturer's instructions. Okay. Concrete and masonry screws. Concrete or masonry screws, also called self-threading anchors, are used to fasten a device or fixture to concrete, block, or brick. They do not need an anchor. To provide a match tolerance anchoring system, install the screw using specially designed carbide drill bits and installation tools made for use with the screws. So these, I think you're going to call these tap cons. They tap concrete. So these tap cons will screw into a pre-drilled hole in concrete or masonry, and then they'll tighten up. The installation tool, along with the appropriate drive socket or bit, lets you drive the screw directly into the pre-drilled holes. The holes have a diameter and depth specified by the screw manufacturer. All right, let's move on. I always feel like I'm taking too long on these. Using thread forming and thread cutting screws. These are called self-tapping or self-threading screws. So thread forming screws, commonly called sheet metal screws, are made of hard metal. They form a thread as they are driven into the work. This thread forming action eliminates the need to tap a hole before installing the screw. This one will actually drill the hole in the screw. You can use a driver to turn this screw, and the tip of it acts like a drill bit, and it'll drill through the material, and then it'll thread its own threads on the way in. To achieve proper holding, it's important to use the proper size bit when drilling the pilot holes for the thread forming screws. The correct drill bit size used for a specific size screw is usually marked on the box containing the screws. Some types of thread forming screws also drill their own holes, eliminating drilling, punching, and aligning parts. Thread forming screws are primarily used to fasten light gauge metal parts together. They're made in the same diameters and lengths as wood screws. All right. So here are a couple examples of those self-threading screws, thread cutting screws. Drywall screws are thin self-drilling screws with bugle-shaped heads. Depending on the type, these screws cut through the wallboard and anchor themselves into wood and or metal studs, holding the wallboard tight to the stud. So drywall screws are very versatile. You can use them for all sorts of things on the job. Here's a coarse thread as opposed to a fine thread. This one says high and low thread. So it's got one thread that's larger and then one that's smaller in between. It's hard to see it from this, but this one is shorter than this one. This one's shorter than this one. Coarse threaded screws are normally used to fasten wallboards to wood studs. Fine thread and high and low thread types are generally used for fastening to metal studs. Some screws are made for use in either wood or metal. A Phillips or Robertson drive head allows the drywall screw to be countersunk without tearing the surface of the wallboard. 2.2.7, using drive screws. Drive screws do not require that the hole be tapped. They're installed by hammering the screw into the drilled or punched hole of the proper size. Drive screws are most often used as part that will not be exposed to much pressure. Typical use for drive screws is to attach permanent nameplates on electrical motors and other types of equipment. So they don't hold a lot. You can't use them to hold a box to a wall, but you can use them to hold a little nameplate to a box. They have very shallow threads. You drill a hole and then you just hammer them in and they'll stay there. 2.3.0, hammer-driven pins and studs. Hammer-driven pins and threaded studs can be used to fasten wood or steel to concrete block without the need of pre-drilled holes. To do so, follow these steps. Insert the pin or threaded stud into a hammer-driven tool designed for its use. The pin or stud goes into the tool with the point end out and the washer seated in the recess. Position the pin or stud against the base material where it is to be fastened. Tap the drive rod of the tool lightly until the striker pin contacts the pin or stud. Strike the tool's drive rod using heavy blows with about a 2-pound engineer's hammer. The force of the hammer blows is transmitted through the tool directly to the head of the fastener, causing it to be driven into the concrete or block. So these are those studs that they're talking about. A lot of times you'll use a powder actuated tool to put these in. They're saying you can do it by hand if you use this drive rod. So this center part moves and you put the stud in one end and then you put it up against the concrete where you want it. The only problem with that is you have to have everything in place. If you're using it to hold a box, the box has to be there. And if you're using a washer, the washer has to be there. And then you get everything lined up. You have somebody help you. They can hold the box. And then you hammer it right into the concrete. For best results, the drive pin or stud should be embedded a minimum of a 1/2 inch in hard concrete or 1 1/4 inch in softer concrete. 2.4.0 Safety requirements for stud type guns. Stud type guns are powered by powder, gas, or spring power. Can drive a wide variety of specially designed pins and threaded stud fasteners into masonry and steel. Powder actuated tools look and fire like a gun and use the force of a detonated gunpowder load to drive the fastener into the material. The load is typically 22 caliber, 25 caliber, or 27 caliber. The depth to which the pin or stud is driven is controlled by the density of the base material in which the pin or stud is being installed, and by the power level or strength of the case powder load. So here's an example of a powder actuated tool, and you cock it just like a gun, and here are your charges or your loads. This strip, if it's a strip, it goes up through the bottom. As you cock it, this will advance one place. So you can fire, and then you cock it, and it moves on to the next one. You fire and cock it, and it moves on to the next one. So it's self-loading. These usually have 10 loads on one strip. Powder loads and their cases are designed for use with specific types and or models of powder actuated tools. They're not interchangeable. Typically, powder loads are made in 12 increasing power or load levels to achieve the proper penetration. The different power levels are identified by a color code system and load case types. Note that different manufacturers may use different color codes to identify load strength. Power level 1 is the lowest power level, while 12 is the highest. Higher numbers, power levels, are used when driving into hard materials or when a deeper penetration is needed. Powder loads are available as single-shot units or for use with single-shot tools. They are also made multiple strip or disc for semi-automatic tools. Warning: only a trained and licensed operator may use powder-actuated fastening tools. The operator must strictly follow the tool operator's manual. If you're licensed, you must carry your license with you whenever you are using a powder-actuated tool. If you see one of these on the job, don't pick it up. Don't play with it. It's dangerous. They're run by gunpowder. They are like a gun, and they can send a projectile flying. People can get hurt. People can get killed. Don't touch them. You must be trained and certified before you're allowed to use one on the job. If you're found using one and you are not certified, you'll be fired. There may be criminal charges. Not kidding. These things are deadly. You need to stay away from them. You may not have to be licensed for some other types of stud guns, but they present very similar hazards and may require special training by your company. So here it says, trained operators must take precautions to protect themselves and others when using a powder actuated driver tool, including the following. Always use the tool according to the published tool operation instructions. Instructions should be kept with the tool. Never attempt to override the safety features of the tool. Never place your hand or other body parts over the front muzzle end of the tool. Use only fasteners, powder loads, and tool parts specifically made for use with the tool. The use of other materials can cause improper and unsafe functioning of the tool. Operators and bystanders must wear eye and hearing protection along with hard hats. Other personal safety gear may be required. Always post warning signs that state powder actuated tool in use within 50 feet of the area where the tools are being used. Before using a tool, make sure it's unloaded and perform a proper function test. Check the functioning of the unloaded tool as described in the published tool operation instructions. Do not guess before fastening into any base material. Always perform a center punch test. Always make a test firing into a suitable base material with the lowest power level recommended for the tool being used. If this does not set the fastener, try the next higher power level. Continue this procedure until the proper fastener penetration is obtained. Always point the tool away from the operator or bystanders. Never use the tool in an explosive or flammable area. Never leave a loaded tool unattended. Do not load a tool until you're prepared to complete the fastening. Should you decide not to make a fastening after the tool has been loaded, always remove the powder load first, then the fastener. Always unload the tool before cleaning or servicing, when changing parts prior to work breaks, and when storing the tool. Always hold the tool perpendicular to the work surface and use the spall, the chip or fragment guard, or a stop spall whenever possible. Always follow the required spacing, edge distance, and base material thickness requirements. Never fire through an existing hole or into a weld area. In the event of a misfire, always hold the tool depressed against the work surface for at least 30 seconds. If the tool still does not fire, follow the published tool instructions. Never carelessly discard or throw unfired powder loads into a trash receptacle. Always store the powdered loads and unloaded tool under lock and key. Here's a case history. I'll let you read it. Masonry anchors. Mechanical anchors are devices used to give fasteners a firm grip in a variety of materials where the fasteners by themselves would otherwise tend to pull out. Anchors can be classified many ways by different manufacturers. In this module, anchors have been divided into 4 broad categories: one-step anchors, bolt anchors, screw anchors, and self-drilling anchors. 2.5.1 One-step anchors. One-step anchors are designed so they can be installed through mounting holes in the component being fastened. This is because the anchor and the drilled hole into which it is installed have the same size diameter. They're available in various diameters and lengths. Common types of one-step anchors include the following. There's a wedge anchor, or a stud anchor, a sleeve anchor, and a one-piece anchor. Like they just said, you drill the same size hole for the anchor, and then you hammer it in. This wedge will spread this collar and make it grip the sides of the hole. This stud anchor will do the same thing. This stud will push up inside, splitting these out. This sleeve anchor is very similar to the wedge anchor in that the bottom is wedge shaped and it will slide into the sleeve. And then a one-piece anchor, as you hammer it in, these bow legs will be bowed out even more and they grip. Here's a screw. We always call these nail anchors because you put it into the hole and then nail this nail into the sleeve, causing the sleeve to expand and grip the sides of the hole. Here's a Sammy anchor. It has a female thread on one side and this male thread that gets threaded into a hole, just like the Tapcons. And then you have the hole that you can put all thread into it, or a bolt, or what have you. Wedge anchors. Wedge anchors are heavy-duty anchors supplied with nuts and washers. The drill bit size used to drill the hole is the same diameter as the anchor. The depth of the hole is not critical as long as the minimum length recommended by the manufacturer is drilled. After the hole is blown clean of dust and other material, the anchor is inserted and driven with a hammer far enough so that at least 6 threads are below the top surface of the component. Then the component is fastened by tightening the anchor nut to expand the anchor and tighten it into the hole. So what they're saying is, as you tighten this nut, you're going to pull some of these threads up through the hole. So you want to have at least 6 threads down. And then as you put the nut on and start tightening it, it'll pull this wedge part up and it'll anchor that wedge anchor in the hole. Stud bolt anchors are heavy duty threaded anchors because this type of anchor is made to bottom in its mounting hole. It's a good choice when jacking or leveling the fastened component is needed. The depth of the hole drilled in the masonry must be specified by the manufacturer to achieve proper expansion. Make sure you don't drill them too deep. If you do that, you're just going to lose the anchor in the wall and have to drill a new hole. Sleeve anchors are multi-purpose anchors. The depth of the hole is not critical as long as the minimum length recommended by the manufacturer is drilled. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until flush with the component. Then the anchor nut or screw is tightened to expand the anchor and tighten it in the hole. One-piece anchors are multi-purpose anchors. They work on the principle that the anchor is driven into the hole. The spring force of the expansion mechanism is compressed and flexes to fit the size of the hole. Once set, it tries to regain its original shape. The hole drilled in the masonry must be at least deeper than the required embedment. Follow the manufacturer's instructions. Here this is highlighted. It says hammer set anchors. Hammer set anchors are made for use in concrete and masonry. There are 2 types, nail and screw. Advantage of the screw type anchor is that they are removable. Both types have a diameter the same size and anchoring of the hole. Both types, the anchor hole must be drilled to the diameter of the anchor and to a depth of at least 1/4 inch deeper than the required for embedment. Follow the manufacturer's instructions. After the hole is blown clean of dust and other material, the anchor is inserted through the mounting holes in the component to be fastened. Then the screws or nails are driven into the anchor body to expand it. It's important to make sure that the head is seated firmly against the component and is of the proper embedment. Hammer set anchors. Did they show us a picture of that? No, I don't see a hammer set anchor. All right. Threaded rod anchors. Threaded rod anchors such as the SAMI anchor are available for installation in concrete, steel, or wood. The anchor is designed to support a threaded rod, which is screwed into the head of the anchor, and the anchor is after the anchor is installed. Special nut drivers available for installing the screws. Bolt anchors. Bolt anchors are designed to be installed flush with the surface of the base material. They're used in conjunction with threaded machine bolt screws. In some types, they can be used with threaded rod. Some commonly used types of bolt anchors include drop-in anchors as well as single and double expansion anchors. So this is what they're talking about. And yes, these will end up to be flush with the material you're anchoring to so that you can bolt something flush to the wall. Here's a standard drop-in anchor. Here's a hollow wall set. Here's expansion anchors, a single wedge and a double wedge. You can see there are wedges at both sides. Drop-in anchors are typically used as heavy-duty anchors. There are 2 types of drop-in anchors. The first type is a standard drop-in anchor made for use in solid concrete and masonry. It has an internally threaded expansion anchor with a pre-assembled internal expander ring plug. The anchor hole must be drilled with specific diameter and depth specified by the manufacturer. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until it's flush with the surface. Following this, a setting tool supplied with the anchor is driven into the anchor to expand it. The component to be fastened is positioned in place and fastened by threading and tightening the correct size machine bolt or screw into the anchor. So the second type is called a hollow wall set. It takes a special adapter to install it. is made for use in hollow concrete and masonry base materials. Hollow set drop-in anchors have a slotted, tapered expansion sleeve and a serrated expansion cone. They come in various lengths compatible with the outer wall thickness of most hollow base materials. They can also be used in solid concrete and masonry. The anchor hole must be drilled to the specific diameter specified by the manufacturer. When installed in hollow base materials, the hole is drilled into the cell or void. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until it is flush with the surface. Following this, the component to be fastened in position is positioned in place. Then the proper size machine bolt or screw is threaded into the anchor and tightened to expand the anchor into the hole. And they talk about the single and double expansion anchors are both made for use in concrete and other masonry. Double expansion anchors used mainly when fastening into concrete or masonry of questionable strength. For both types, the anchor hole must be drilled to the specific diameter and depth specified by the manufacturer. Screw anchors. Screw anchors are lighter duty anchors made to be installed flush with the surface of the base material. They're used in conjunction with sheet metal, wood, or lag screws, depending on the anchor type. So this is what they're talking about. You've seen these, you've bought things before that came with these little plastic inserts. You drill a hole and you put the insert in the hole and then you can screw into it. It expands as the screw goes in. There you go. Yeah. Fiber and plastic anchors are typically used in concrete and masonry. Plastic anchors are also commonly used in wallboard and similar base materials. The installation of all types is simple. The anchor hole must be drilled to the diameter specified by the manufacturer. Minimum depth of the hole must equal the anchor length. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until it is flush with the surface. Self-drilling anchors. Some anchors made for use in masonry are self-drilling anchors. The one in figure 47 is typical of those in common use. The fastener has a cutting sleeve that is first used as a drill bit and later becomes the expandable fastener itself. A rotary hammer is used to drill the hole in the concrete using the anchor sleeve as the drill bit. Let's take a look. There you go. So here, this is the part they're saying is going to be used as the drill bit. And then once we get the hole drilled, then we're going to put the wedge in and make this part of the anchor. Drilling anchor holes in hardened concrete or masonry. When selecting masonry anchors, regardless of the type, always take into consideration and follow the manufacturer's recommendations pertaining to the hole diameter and depth, the minimum embedment in concrete, the maximum thickness of material to be fastened, and the pull-out and shear load capacities. When installing anchors and/or anchor bolts into hardened concrete, make sure the area where the equipment or component is to be fastened is smooth so that it will have solid footing. Let's see here. Let me look at the drawing. There we go. So step one, you drill the hole to the depth specified by the manufacturer, and you're going through the material to be anchored. You've already got it in place. Then you put this anchor through the hole in the concrete or masonry, and you hit it with a hammer, get it till it's flush. And then as you start tightening it, what's going to happen is these threads are going to pull up on the sleeve, and the sleeve is going to or the wedge is going to cause the sleeve to open and bite the sides of the hole. So they're really good anchors. And the thing is, if you don't succeed the first time, you can remount these. Like if you pulled up on it and you got it too long, the length of the stud showing, you realize that you really didn't get a good grip on it. You can loosen this nut up back to the top, take your hammer and re-hammer it down into the hole. And a lot of times what happens is dust and debris will fall through the sides and get wedged in between the anchor and the side of the hole, so that the second time that you go and tighten the nut, it will then bite. You'll get a good bite on it, and you'll get it nice and tight, and everything will be fine. Warning, drilling in concrete generates noise, dust, and flying particles. Always wear safety goggles, ear protectors, and gloves. Make sure other workers in the area are also wearing protective equipment. Follow your company's silica rules to prevent exposure to concrete dust. Okay. And then they tell you what we just did. Drill the anchor hole to the same size as the anchor bolt. Drive the anchor bolt into the hole using a hammer. Put a washer and nut on the bolt and tighten the nut with a wrench until the anchor is secure in the concrete. Hollow wall anchors. When you must attach to hollow materials, use hollow wall anchors. Installations where these anchors would be used include concrete planks, blocks, structural steel, wallboard, or plaster. Common hollow wall anchors include toggle bolts, sleeve-type wall anchors, wallboard anchors, or metal drive-in anchors. So installing toggle bolts. This is a toggle bolt. Reason for that is because the head of it will toggle. These will swing down, they're on a spring, and you can swing it down to where this anchor takes up a lot less room. You could fit it through a hole. Once you get it past the end, these two arms will spring back straight, and then as you start tightening, it will back up against the material, usually drywall. Here's a plastic toggle that you can push this almost straight, and then as you get it up through the hole, it will have a tendency to try to come back to a natural position, and then you can put a screw in and catch it on the end here. And as you start tightening it, this is going to come down flat until it's flush against the drywall. So here, round head, flat head, they sometimes call these countersunk. Here's a mushroom head, a button head, or slotted head. This one has a tie wire toggle bolt. You can put tie wire in here. A fixture hanger. It's 11 inches across when it's open. Once the toggle bolt's installed, be careful not to completely unscrew the bolt because the wings will fall off, making the fastener useless. Screw-actuated plastic toggles are also made. These are similar to metal toggle bolts, but they come with a pointed screw and do not require as large a hole. Unlike the metal version, the plastic wings remain in place even if the screw is removed. Toggle bolts are used to fasten parts to hollow block, wallboard, plaster, panel, or tiles. Use the following steps to install a toggle bolt. Select the proper size drill bit. Check the toggle bolt for damage or dirty head. Threads. Drill a hole completely through the surface to which the part is to be fastened. Insert the toggle bolt through the opening into the item being fastened. Screw the toggle wing into the end of the toggle bolt. Fold the wings completely back and push them through the drilled hole until the spring opens. Pull back on the item to be fastened to hold the wings firmly against the inside surface to which the item is being attached, and then tighten the toggle bolt with a screwdriver until it's snug. Think about it. What will happen if you tighten a toggle bolt too tightly? Well, you'll break the drywall. It'll come right through it. Installing sleeve-type wall anchors. Basically, the manufacturer is going to tell you what size hole to drill, and then as you put these in and start tightening, this will accordion. It'll fold, it'll shorten up, and it'll make its own kind of a toggle. It'll hold against the back of the drywall. These just get screwed into a hole in the drywall. You make a nice clean hole, you screw these in, and the threads are what hold it in place. Then you can put a smaller threaded screw inside the sleeve. Metal drive-in. I've never used these. I don't know how they work. I have to be honest with you. Looking at the drawing, I'm trying to figure out how they would function. I don't know. I guess you put these through the hole, and then as you put the screw in, it's going to make these lay back on themselves as the screw gets screwed in. I don't know. All right. So installing wallboard anchors, it says drive the anchor into the wall with a Phillips head manual or cordless screwdriver until the head of the anchor is flush with the wall or ceiling surface. Position the component being fastened over the anchor. Secure the component with the proper size sheet metal screw driven into the anchor. Okay. Installing metal driving anchors. Metal driving anchors, like the ones shown in Figure 50, are used to fasten light to medium loads to wallboard. You have two pointed legs that stay together when the anchor is hammered into the wall and spread out against the sides, the insides of the wall when the sheet metal screw is driven in. All right. I guess that's what they're talking about. Yeah. All right. Again, I've never used one like that. Epoxy anchoring systems. This is some of the best anchoring systems you can use because once the epoxy is hard, nothing's moving. You can use epoxy resin compounds to anchor threaded rods, dowels, and similar fasteners in solid concrete, hollow wall, and brick. A two-part epoxy is typically packaged in a two-chamber cartridge that keeps the resin and hardener agent or ingredients separated until use. This cartridge is placed into a special tool similar to a caulking gun. When you pump the gun handle, the epoxy resin and hardener component are mixed within the gun. Then the epoxy is ejected from the gun nozzle. So drill a hole in the proper size in the concrete, clean the hole using a nylon brush, dispense a small amount of epoxy from the gun to make sure that the resin and hardener have mixed properly. You can tell because the epoxy will be a single color. Place the gun nozzle into the hole and dispense the epoxy until half of the depth of the hole is filled. Push the selected fastener into the hole with a slow twisting motion to make sure the epoxy fills all voids and crevices. Then is set to the required plumb or level position. After the recommended cure time for the epoxy has elapsed, tighten the fastener nut to secure the component or fixture in place. So don't do anything with the nut until after this is cured for 24 hours. You want it to harden. Procedure for installing a fastener on a hollow wall or brick using epoxy is basically the same as that described for the solid concrete. Here's section 2.0.0 review. It's recommended that zip ties that will be used outdoors. You remember us talking about that? I'm not going to answer these. I'll let you answer them. Which of the following is true regarding screw gauges and shank sizes? When installing hammer-driven pins and studs, when using a powder-actuated tool, the type of fastener that uses the anchor itself to drill as a drill bit is what kind, and the type of fastener with spring-loaded wings and epoxy anchoring systems are commonly used to anchor fasteners in what? Okay. Very good. We'll go on to the next section. I'll see you on the next video.